In this video we shall discuss several cases of joins with count usage. In the first task we have to show all books having more than one author. And here they are. You see two authors here for this book and two authors here for this book also. The solution for this task is the next. We have to select book ID, book name, and then we have to count book authors. To achieve that, we have to group our results by book ID. Pay attention that we cannot use book name field here, because if we have two or more books with the same titles, the result will be incorrect. And the only thing left is to apply such a condition. The authors count should be greater than 1. And solutions for Microsoft SQL Server and Oracle are exactly the same. One other thing we have to mention is that we have to use having keyword here in all our queries. We cannot use where keyword because where works during the query execution, and the count result is only available after the main section of query execution is completed. And having keyword applies its condition after the main part of the query execution is completed. In the second task, we have to show for all books how many copies of them are now available in the library. Here is the result. It is quite simple, but the solution is not as simple as it may seem. For each DBMS we shall review several variants of solution, and we shall start with MySQL and with the first variant. Here we use correlated subquery. For each book we select book ID, book name, the quantity of copies of that book registered in the library, and then we have to calculate how many copies of that book are now taken by subscribers. And this correlated subquery does exactly that thing. Why is it called correlated? Because we have to use the same table here and here. And here we rename it as external and here as internal. And then we apply a condition that identifier of a book from internal table should be equal to the identifier of the book from external table. So that's the correlation between internal data and external data. And that's why such subqueries are called correlated. Let's see some more explanation. If we modify that query, we take that part and transform it into this, we may see that this whole part becomes that value. And here we go deeper with step-by-step explanation. Let's copy this part and place it here. Now we see our initial book quantity, the information about how many copies of each book is registered in the library. Here it is. Then we see how many copies of a book were taken by subscribers. Here it is, and it goes here. And then we produce the final result as this minus this. And that's all. This is how this query works. With another approach, we may use correlated subquery and common table expression. Here is our common table expression. Here, for each taken book, we calculate how many copies of that taken book are taken by subscribers. But then in the main part with this subtraction, we have to use if null function, because for those books not taken by subscribers, the result from here will be null. And for that subtraction to work correctly, we have to transform that null into zero value. With the next variant, we shall use correlated subquery and two common table expressions. The first one will produce a list of books taken by subscribers. The next one will count how many copies of a book are taken by subscribers. And for those books not taken by subscribers at all, the result will be zero here. So that is why we do not need any function to transform nulls into zeros in this part of the query. And we may even achieve the same result without subqueries at all, with only one common table expression. Here we count for each book how many copies of that book are taken by subscribers. But those books that are not taken at all, the result will be null here. So that is why we have to use ifNull function to transform that nulls into zeros. With Microsoft SQL Server we follow the same approaches. The first approach is correlated subquery. Once again we count how many copies of a book were taken by subscribers, and then we use the number of copies of book registered in the library and subtract this value. With the second variant, with correlated subquery and common table expressions, we see some more explanation here than we saw with MySQL. This is the result produced by common table expression, and you see that not all books are listed here. For those not listed, the result from that column will be, of course, null. And that is why we have to use isNull function to transform that null into 0. With the third approach, we use correlated subquery and two common table expressions. The first one returns such data, the second one counts for each book, for each and every book in our library, how many copies of that book are taken by subscribers, even if it's 0. And because we already have those zeros here, we do not need to transform anything there. With the fourth variant, without subqueries, we use only one common table expression. Here we have the number of copies of a book taken by subscribers, but only for those books that were taken by subscribers at all. For those not taken at all, we have null here, and that is why we have to transform that nulls into zeros. And for Oracle, we may follow the same ideas. We may use correlated subquery to select quantity of a book in the library and to subtract this quantity of that book taken by subscribers. In the second variant, we produce the information about how many copies of a book are taken by subscribers here in the common table expression, and then we use correlated subquery here to produce our final result. With the third variant, we use two common table expressions, and the first one gives us the list of books taken by subscribers. The second one counts how many copies of those books are taken, even for those books that are not taken at all. And here we see our correlated subquery. Because this information contains data for each and every book, we do not need to transform nulls into zeros here. And with the fourth approach, we do not use subqueries, we only use common table expression. We count information about how many books are taken by subscribers, but only for those books that are taken at all. So here we have to transform nulls into zeros for this subtraction process to work correctly. And you may wonder which variant is faster. Here's the answer. Please pay attention to the difference. Here we have 0.3 seconds and here we have about 10,000 seconds. Here we have something about 5 versus 50. Here we have 0.3 versus 1.4 or something like that. It is not as impressive as in MySQL case, but it's significant nevertheless. And also pay attention that for MySQL the first variant is the fastest one, for Microsoft SQL Server the fourth variant is the fastest one, and for Oracle the third variant is the fastest one. This example shows how important performance testing and performance optimization is. So always try to make some experiments to determine which approach is the fastest one in your particular situation.